Okay. So let us start with an example about projections and components, that kind of thing. So this example is like this, that two vectors A and B, suppose, are directly given to us like this, that the vector A is, let's say, now if C is a vector in the plane of A and B and perpendicular to A, such that mod C is equal to 3 units. Okay, then draw C in the diagram shown. And express C in component form. Okay, that is the first thing we'll do. So start with this question. Then if D is the projection of vector A parallel to B, then again find D and draw the vector D in the diagram. Okay, and now if E is a vector perpendicular to the plane of A and B, okay, such that magnitude of E is equal to 4 units, then express vector E in component form again. So just try these 3 parts out, people. It will be a complete sort of review and complete test of your understanding of the application of dot and cross product. Okay, so obviously you make the diagram in your notebook only, but after making the diagram, when you've expressed these vectors C, D, and E in component form, just send it to me in the text message and I will verify for you if it's correct or not. Okay, so let me give you a little bit about a hint of how you can express the vector c. Let's just look at this. So see, for this, what you can do is you can make use of the concept of the perpendicular projection. Okay. So just pay close attention to what I'm doing in the diagram here. So now see, in this, I want to express the vector c as a vector perpendicular to A, but in the plane of A and B. A, है ना? Okay. And magnitude of C is 3. So I want to find out what this vector C is. Okay, this is what I'm trying to do. Perpendicular to A, like this. Okay. So in the diagram, let's first understand which is the direction which is perpendicular to A but lying in the plane of A and B. That is nothing but this direction. SI axis, we can draw an axis like this which is perpendicular to A but lying in the plane of A and B. If you draw a parallelogram or a triangle using A and B, it lies in the plane of the screen. So this is the axis which is perpendicular to A in the plane of A and B. This is the first thing. Okay. So now if I want to define a unit vector along this axis, let's say m cap. Okay, this is a unit vector along that axis. Then what will be my vector c? My vector c will therefore become either plus or minus of 3 times that unit vector. So I just need to find out this thing. The unit vector, okay, along this axis. Which axis? This one. ये निकालना है मुझे. So now the hint to you for this is, think of the vector b perpendicular. Okay, where does that lie in this diagram? And you will immediately understand how to find the unit vector m cap. And then you know how to find the b perpendicular vector. Now you know that as the application of dot product. So make use of that. So hope you understood what I've explained in the hint. Okay, and then you can use your knowledge of the application of dot products to try and solve this. Okay, so let me explain, since I'm hardly getting answers from one or two people. So what we will do here is, first step, we will calculate these two components of B. The component of B parallel, and from that the component of B perpendicular. So we need to find out this. Basically we need this B perpendicular, but as you know, to calculate B perpendicular we first need to calculate B parallel. You cannot calculate B perpendicular directly, there's no formula for that. So B perpendicular is along the unit vector m cap. So that was the hint actually. So we need to find m cap now. So to find m cap, we first need to find b cap, B perpendicular. We need to find what this vector is. Okay. So for that we use the standard method that the parallel component is b cos theta into the unit vector of A in this case. So b cos theta you can see is by formula A dot B divided by magnitude of A this time, because we are finding b cos theta. So A dot B kitna hai? You can calculate from here. A dot B will be 1 into 2, that is 2, plus root 2 into root 2, so that is 2, plus 0 into, so it's 4. So 4, and magnitude of A you can see is square root of 4 plus 2 plus 2, so that is 2 root 2, square root of 8. So this is root 2. Okay, and A cap is how much? It is vector A divided by magnitude of vector cap plus root 2 j cap plus root 2 k cap divided by 2 root 2. So we can write this as 1 by root 2 I cap plus 1 by 2 j cap plus 1 by 2 k cap. Okay. So from this and this, now we have this thing. The parallel component is b cos theta, which is root 2, multiplied with a cap, which is, and you can just leave it this way, or we can take this root 2 inside, so it will become I cap plus 1 by root 2 j cap plus 1 by root 2 k cap, like this. This will become B's parallel component. So now the question is, what is B's perpendicular component? So B's perpendicular component, as you know, is the vector B minus the parallel component. So it is I cap plus root 2 j cap minus this component. So that was, okay. So 1 minus 1, so that's 0 I cap plus root 2 minus 1 by root 2, okay, j cap plus 0 minus 1 by root 2 k cap. So this is 0, this will become 1 by root 2 j cap minus 1 by root 2 k cap. So ये हो गया मेरा B parallel. Okay. So we reach the story up to here. Okay. So now M cap is the unit vector along B parallel now. Sorry, B perpendicular now. So that means M cap is nothing but the vector B perpendicular divided by its own magnitude. So it is 1 by root 2 j cap minus 1 by root 2 k cap divided by, now it just so happens कि इसका magnitude already 1 है, so it's already a unit vector. So m cap is this one only, it is j cap minus k cap by root 2. Okay. So therefore, so this is the unit vector which is along that axis perpendicular to A. Okay, in the plane of A and B, which I had shown in the diagram also. That is that unit vector. So therefore the vector C is either plus or minus of 3 m cap. So the vector C is plus minus 3 by root 2 into j cap minus k cap. It can be plus also, it can be minus also. There are two possibilities for the vector C. Because going back to that diagram, that vector C could be along the axis of m cap, or it could be along the negative axis of m cap also. Okay. So the vector C in this diagram can be one of these two vectors which I am drawing. It can be a vector like this, ऐसा भी हो सकता है, of magnitude 3, or it can be a vector like this also. Okay, so it could be along. Okay, so this could either be plus 3 m cap or minus 3 m cap, where m cap is this unit vector. Okay. So just go through this in detail step by step once, then we'll come to the second and third part. Okay, so if you finish writing down this part, then you can now come to the second part where you have to find the vector, this one, the vector D, which is a projection of A parallel to B, where D is the projection of the vector A parallel to the vector B. So this is a direct question. This you can do by just direct formula of the parallel projection, which you have seen even in application in this question. But here we remember we had found out the projection of B parallel to A, whereas D is the projection of A parallel to B. So it's like the inverse application of that. Okay, so anybody got the answer for D or not? I'm waiting, people. This second part is very easy. Just work this out quickly and send the answer to me. Everything you need is there on the board. The vectors A and B you can see. Ideally, you should have written them down also earlier. Okay, work it out quickly. नहीं, √3 वाला फैक्टर कैसे आया हूँ? Okay, let me explain. So let's pick up the original diagram again. So we want to find the projection of A along the vector B this time. Not B along A, but A along B. So first of all, let's understand what that is in the figure itself. Okay. So this is the axis of the vector B. So ये वाले axis के along मुझे A का projection निकालना है. So what I have to do is I have to drop a perpendicular on this axis from A. From A's head to drop a perpendicular. Okay. And then whatever component A cuts along this axis, this becomes A's parallel component along B, whereas if we similarly take a perpendicular one, it's actually, my diagram is little inaccurate. Let me make a more accurate diagram. So it's more like this. यहाँ से अगर मैं perpendicular ड्रॉप करता हूँ ऐसा है. So this is the perpendicular component, this is the parallel component. So this is what we have to find here actually. We don't even have to find the perpendicular component. This is what we have to find because this is what our vector D is. It is the projection of the vector A along the vector B. Right? This is what we need to find out. So इसके लिए we have that direct method ना, that its magnitude is A cos theta and its direction is along B, so it's B cap. So now just find out A cos theta from the dot product. Okay. So dot product we had already seen A dot B was 4, right? 1 into 2 plus root 2 into root 2. Okay. And this time B's magnitude we find out. So that is square root of 1 plus 2. So root 3. Okay. So this is becoming this thing. How much is it? 4 by root 3. Okay. And what about B cap? That is vector B divided by its own magnitude. So that is I cap plus root 2 j cap. Okay. So that's why there won't be any root 3 term because you're multiplying these two. No? So your vector D, which is directly this parallel component, doing nothing but 4 by root 3 multiplied by this unit vector I cap plus square root of 2 j cap but divided by root 3. So finally there's no root 3 term. Okay. So maybe there was a calculation mistake involved. Just check it out. So this is 4 by 3 times I cap plus root 2 j cap. Or you can express this also as 4 by 3 I cap plus 4 root 2 by 3 j cap. Both the ways of expressing are fine, there's no problem with it, but this is the vector in component form. Okay, and you can see this is the meaning of it, this is the geometrical meaning of it, this only is the vector D in the diagram. Okay, so this is the second part of the question, and the third part is a slightly different application. So see if you can pick it up. We have to find out the vector E such that E is perpendicular to the plane of A and B. Okay. And magnitude of E was I think 4 units. Okay, so what about the answer for E? Anybody's got it? Om, you understood now why their denominator may you should not have this root 3 factor. It should be okay, good. But you applied the same method, the same concept. Okay. Now let's come to this part. Now this is actually also a very direct question, because from this you will understand that the vector E should be plus or minus 4 of n cap, let's say, where n cap is a unit vector which has that property that it is perpendicular to the plane of A and B. Now, if you just recall your basics of vectors, you'll understand which is this unit vector. You'll recall that A cross B is a vector whose unit vector has this property. It is perpendicular to the plane of this. So this n cap is the same as this. It is a unit vector which is perpendicular to the plane of the given two vectors, or plane of the parallelogram formed by A and B, or the triangle formed by A and B or whatever. So indirectly you have to just calculate the cross product, and from the cross product you have to find this unit vector. So what you have to do is you have to find n cap, because to find E you need to understand what is n cap. So what is n cap? That is coming from here. It is A cross B divided by its own magnitude. Now that is very easy because you know a method of calculating A cross B. Given the vectors A and B in component form, you know that matrix based method. So just use the same values of A and B over here to calculate the cross product, then divide it by its own mod. So you will get the unit vector. And then your vector E is a vector of magnitude 4, either along that unit vector or exactly opposite to that unit vector. So it's just a two-step process. First you do the cross product, and from that you find n cap, and then you express the vector E in terms of that n cap. Okay, very good. Plus minus. So you have to add the plus minus sign here. So vector A is 2 I cap plus root 2 j cap minus root 2 k cap, and vector B is I cap plus root 2 j cap. So first thing is you calculate A cross B. Plus था minus था? Minus था. Okay. So this is our vector A cross B. Okay. So that means our n cap is this vector divided by its own mod. Okay. So whichever way we express it, this is our n cap. So E is either plus or minus 4 of n cap. So E is either plus or minus of, you can write this as, Okay, so hope this is clear to all of you. All right. So let's. So this was a proper revision of the concepts of dot and cross product and applications. So this question you can sort of keep it handy in your own notes. So in future, anytime when you're revising for a test or for just in general, if you want to revise the application of dot and cross product in vectors, you just need to go through this question, and everything you need in dot and cross product concept is there in this question, including projections, the application of projections. So you can keep this example and the concept that we have discussed, how to solve this example in your own revision notes, and it will help you revise quickly in the future also. Okay, now next let's move on to another question, and through this question we'll also discuss another shortcut method and theorem which will be very useful for us in this thing Newton's laws chapter later. So this is about, this next example is about the, basically it is about equilibrium of three forces, but it can be applied to any three vectors, need not be just forces. Okay, so I'll say equilibriums of three forces type of problem. Okay. So this is basically, this is about the condition for the sum of three vectors a plus b plus c to be equal to 0. Okay. So for example, if a, b and c are forces, are force vectors, okay, then this is the equilibrium condition, because net force 0 का मतलब ही equilibrium होता है. Okay. Then this is the equilibrium condition. That the net force, which is the sum of the three forces, should be 0. So that is what we mean by equilibrium of three forces. Okay. So we will do this as an example question first, and through that we will develop the theorem further. So in my example, this is, let us say, vector A. This is, let us say, vector B, and this angle is, let us say, 120 degrees, and this is vector C, where this angle is 150 degrees. Okay. So the question here is that if the magnitude of the vector A is 12 units and A plus B plus C equals to 0, then find the magnitude of B and the magnitude of C in the same plane, or basically they are coplanar. Later today we'll also discuss a little bit about coplanarity of vectors. So just try out this question, people. So the one way you can do is you can do by component method. You can use component notation. or you can use triangle law and do that also, that a plus b plus c is equal to 0 can be expressed as c is minus of a plus b, or b is minus of a plus c, or a is minus of b plus c. Any of these you can make use of. Any of these or component notation. In this particular question, one very easy thing you can notice is that this angle is 90, because it is, how this angle is becoming 90 is because it is 360 minus of 150 plus 120. So it is 90 degrees. So that means these two vectors are perpendicular to each other. So it makes the geometrical approach very easy. It makes the application by triangle law very easy, that if you draw these same vectors head to tail, now you know that the vector C is like this. To that, if you add the vector B, B is at 90 degrees with respect to C. So you'll get a right angle triangle. This angle is 90 degrees. This is your vector B. Okay. And therefore the vector A has to be like this now. It just has to be, diagram has to be modified a little bit, but so the vector A is like this with C actually stretching out like this. So C should be like this. Just a minute. Just a minute. I'll get back with the diagram. Yeah, so C has to be this way. Okay, now the given information to us is about A's magnitude, it is 12 units. Okay, also if you see the angle between A and C, so that is this angle over here, that should be 120. That means this internal angle, sorry, that's 150. So that means this internal angle is 30. Now this is the direction of A. So this angle, yeah, you can see this angle is the same as this, 150 degrees. So that means this is 30 degrees. Okay, and likewise the angle between B and A. This is the direction of B, this is the direction of A. So this angle here, this angle is 120 degrees. So this angle is 60 degrees. So now that makes life very simple. This is the condition for A plus B plus C to be 0. They should form a closed triangle. Okay, that is A, B, and C are consecutive sides of a closed triangle when drawn head to tail. That is a condition for the resultant to be 0. Okay. So now in this you can see that magnitude of C upon 12 is sine 60. So that means C is equal to 6 root 3 in magnitude. And magnitude of B upon 12 is cos 60. That means magnitude of B must be 6. So these are the final results from you. So this is one way of doing the question. Okay. Because we figured out that that angle between these two vectors is 90. So it was easy to start with the geometrical method. Now I'll also show this to you by component algebra method. Okay, so hope this method is clear to all of you. Now let us see how we can deal with this using component algebra. That's also reasonably easy. Yes, wait, 30 60 90 से किया ना? That was what we did. Okay, now if we are doing this by components, what we'd want to probably do is, because A is the vector which is known to us, so we will take the direction of A as one of our axes and divide the other two into components. So let's do that. Okay, so let's take the direction perpendicular to A as our x-axis. Let's take the direction along the vector A as our y-axis. And A was given to us in magnitude to be 12 units. So now from these angles which are given, we can also see that this angle is 120 minus 90, so it is 30 degrees. And this angle on the other side is 150 minus 30, so it is 60 degrees. And your y-axis continued is just like this. Okay. So this is the vector C and this is the vector B. So now let's express A, B and C in component form. So A is just 12 j cap, simplest of the lot. B का मुझे magnitude नहीं पता, but the components will become B cos 30 and minus B sine 30 j cap. You can see that clearly from the diagram. If you drop these perpendiculars, so it is root 3 times B by 2 I cap minus B by 2 j cap. And similarly, the vector C has a negative x component of cos 60 and a negative y component of sine 60. So this is minus C by 2 I cap minus C times root 3 by 2 j cap. So A plus B plus C we can do like this now. It will become 0 plus B root 3 by 2 minus C by 2 I cap plus 12 minus B by 2 minus C root 3 by 2 j cap. And we want the condition that this should be 0. This is the condition that we want, that this should be 0. So this should be 0 individually, and along with that this should also be 0. Both of them should be 0. So this tells me that C is equal to B root 3. Okay. And so that's my first equation, and this tells me that B plus C root 3 is equal to 24. That's my second equation. So now substitute this here. So B plus B root 3 into root 3 is equal to 24, or B plus 3B is equal to 24. So that tells me that the magnitude of B is 6. And that tells me that the magnitude of C is 6 root 3. Okay. So I think that is what we've seen. We'll agree with what we got by the. So, when in doubt, there is always the component method. That never goes out of the picture. The component form or the component method of solving is always an option for us. It's just that sometimes it is not the easy option. There is a faster option by using geometry, and sometimes it is the geometrical method will become lengthy, and this is the feasible option. Okay, so hope this method is also clear to all of you. Now we will end today's session by learning a special theorem called Lamy's theorem, which is basically a special theorem on the condition for specifically the sum of three vectors to be a null vector, or for equilibrium of three forces type of situation. Okay, so the statement of that theorem is like this, that if your three forces are like this, or your three vectors, they need not be forces, and there's no necessity that two of them have to be perpendicular or anything. Okay, they are some arbitrary coplanar vectors. So A, B, and C are coplanar vectors, okay, such that the angle between B and C is denoted by alpha. The angle between A and B is denoted by gamma, and the angle between A and C is denoted by beta. So these are these angles. So such that alpha is the angle between B and C, as you can see in the diagram. Beta is the angle between A and C, and gamma is the angle between A and B. Then, according to Lami's theorem, condition for their resultant sum to be zero is that magnitude of vector A divided by sine of alpha is equal to magnitude of vector B divided of sine beta is equal to magnitude of vector C divided by sine gamma. So this becomes like a shortcut method of solving this type of question. So this is called the statement of Lami's theorem, which is a condition for this. Okay. The statement is a necessary condition for the resultant of the three vectors to be zero. So just make a note of this, and we will see the application of this in the previous question also. Okay, so let's quickly apply this to the previous question so we can wind this up. So you'll see the previous question becomes very, very quick when we apply this, because there the magnitude of the vector E was 12. Then vector B was unknown in magnitude, but this angle was 120 degrees. And vector C was unknown, but this angle was 150 degrees, which means that this angle was 90 degrees. Okay. So this was right angle. So now this condition here becomes that magnitude of A upon sine 90 should be equal to magnitude of B upon sine 150 should be equal to magnitude of C upon sine 120. So magnitude of A was 12, sine 90 is 1. That should be equal to B upon sine 150, which is half. That should be equal to C upon sine 120, which is sine 60. So that is root 3 by 2. So directly you can see that B is equal to 12 into half, or 6, and C's magnitude is 12 into root 3 by 2, or 6 root 3. So these become one line solutions. Okay. Now because this type of question, the equilibrium of three forces is going to be very common in Newton's laws. So it is important to have this well understood as a shortcut method. So this is a very important shortcut theorem. So though we can also find this condition by using basics of vectors like component algebra or triangle law, but from this point onwards, whenever we are dealing with the condition for the resultant of three things to be zero, A plus B plus C to be zero, instead of doing by basic method, which is a little bit time taking, we will always use this method called the Lami's theorem. Lamy was the name of a mathematician, hence that strange name. Okay, so people, that's it for today's session. Hope you understood this. And now to wind up, wishing you a very happy Diwali. Okay, do enjoy with your family and friends as much as possible. But like I said, just take a couple of days out of your Diwali vacation to run through the previous chapters in all subjects and identify areas where you need to work a little bit on the basics again, so that the studies from there onwards will be smooth for you. Okay, so that's it, people. Happy vacations, happy Diwali. Have a great time. Bye.